Alright, welcome back for another lab demonstration. We've got our shop car here once again. Let's go over the vehicle information block and filling that out. We'll start with the year of the vehicle, and we'll show you the VECI sticker up here. Let me bring you in for a close-up. Alright, so the VECI, or the Vehicle Emission Control Information sticker, can be found under the hood of most vehicles that haven't been repaired or repainted usually. And this has some standardized information on it. However, the actual layout or appearance of it can vary from one manufacturer to the other. A couple good pieces of information to know that you can find on it would be the vehicle year. So if we read this little paragraph or sentence right here, this vehicle conforms to the U.S. EPA, NLEV, and CFV and California regulations applicable to the gasoline fuel 2003 model year ULEV passenger cars. Okay, so that right there tells us it's a 2003 model year, regardless of what the date of manufacture on the driver's side door is. This is what we're going to go by. Unless, of course, it's not the original hood. That would be not good. But oftentimes, you would kind of have some other telltale signs. Some other piece of information while we're here is right here. You can see it's a 1.7 liter. And then if we need to, we have a vacuum hose routing diagram. And this one was nice enough to point out where our PCV valve is. And we'll come back to this later. Okay, so let me set you guys back down and we'll go through the rest of it. Alright, so now that we know that it's a 2003 for our year, and we know that its engine displacement is 1.7 liters, we can move on to some of the other items in the vehicle block here. We got a few new ones too. Cylinder arrangement. I have 1, 2, 3, 4 cylinders. These are the ignition coils for the cylinders. We can see that they're all in a row or in a line. So that means that we would be an inline 4-cylinder. No, this vehicle is not a hybrid. Engine mounting. The belts for the engine are on this side and they're pointing towards the driver's side of the car. So the back side of the engine here is pointing towards the passenger side of the car. So that makes this engine transversely mounted because it's mounted the width of the car and not the long way or the longitudinal way of the car. The engine location happens to be in the front of the car. That one's pretty obvious. And then the body style, if we bring it out a little bit, we can see we've got 2 doors on this side, obviously 2 doors on the other side, and a trunk, so that makes this a sedan. And then on our block here we've got ignition system, and as pointed out earlier, you can see we got a picture to help you out here. We've got ignition coils that look very similar to this, so that means that we have coil on plug ignition. Fuel system. Carburetors haven't been around for quite some time. Throttle body injection is a pretty older fuel injection system nowadays. This particular one has multi-port fuel injection. Let me see if I can give you guys a closer up look at the fuel injectors. They're a little bit hard to see with everything fully assembled, but bear with me while I pick you up again. See if we can move you. So if we come to the engine, this is the exhaust side of the engine. That's the exhaust manifold with an oxygen sensor there. And if I look over the top and down, if I shine some additional light down there and see if I can get you guys in the right angle. That little black connector down there with the yellow wire going to it, that is the top of the fuel injector where the wire clips on. Okay, so this particular one is difficult to see. Here's another one right there. You can see the yellow wire in the top. There's the top view of the fuel injector again. This is one of those ones, this is one of those engines where you just have to take my word for it for now and why we still need to do some of these exercises in person, and so that you can see for yourself. Taking a look at our list here, we've got some optional accessories to identify: air conditioning, power steering, EPS would be electronic power steering, power brakes, anti-lock brakes, and airbags. So right away, if you take a look at this line right here, it's a kind of a larger diameter, heavy rubber line, goes to aluminum line. And then if I move my light, right down here, there's a little cap, and this particular one has an L on it. This is my low side line for my air conditioning system. So the air conditioning compressor on this vehicle is underneath the alternator, which is underneath the power steering pump. So there's power steering pump, alternator, and then air conditioning compressor. Let me see if I can get you guys a better visual of the air conditioning compressor. But this line is pretty much a dead giveaway that this vehicle at least was originally equipped with air conditioning. Now whether it works or not, that's a whole other question. So here's the low side line. Follow that down, there's the test port. We keep following that down, and you can see where they bolt on right there. That would be the compressor, and directly above it is the alternator, and then that would be the backside of the power steering pump there. And then there's an airbag symbol on the steering wheel, so we know that the vehicle has airbags. After you get that filled out to the best of your ability, bring it over to me. We'll take a look at it, have a conversation about things, and then we'll keep moving on to doing some under the hood fluid checks. So we'll start with our engine oil once again. With the engine having been off for a little while, we can go ahead and find the engine oil dipstick and give it a pull. Remember, always wipe it first. Then we want to take a look at our dipstick to figure out where the high and the low is, or the add and the full marks, so we know how to read it proper. This one, just like in the last video, it just has a dot for the add and a dot for the full. Pull it out, and we can see it's right at that second or full mark, so we're good. Up next, we'll check the transmission fluid. So if the engine's here, that means the transmission's underneath here, and you can see my dipstick handle is the yellow loop right there. Let me go ahead and put you back on the tripod. We got to turn on the exhaust, because anytime we check automatic transmission fluid level, we want the engine running. I already have the hose hooked up, so all I got to do, turn on the exhaust. Come over, engine running. As with before, I'm going to wipe it off and make sure I know how to read my dipstick. Check the level. Record what you find on the sheet. Again, for automatic transmissions, the vast majority of them need to be running when you check them. This is where we need to refer to manufacturer's specifications and requirements. That's assuming that your automatic transmission in the vehicle you're doing this lab on actually has an automatic transmission dipstick. Some you will find do not, and they have plugs that need to be pulled. We will go over those on a case-by-case basis. Moving on, we are now going to take a look at the engine coolant. You can use an inspection mirror and a light on this particular vehicle to check out the level in our overflow tank. Okay. This time we're going to go a little bit further, and we are actually going to do a test with some coolant test strips to determine the freeze point and the pH or acidic level of the coolant. So I've got my radiator cap exposed here. As a reminder, we never want to open these when the engine's hot. The engine was only running for a matter of seconds after sitting all night, so it's not hot, so I can remove it safely. I still want to be careful about it though, because I don't want to create a mess for myself. So this is the type of cap where you got to push down and turn counterclockwise to loosen it. Some of these radiator necks, it might actually be hard to get the test strip into the coolant because of the narrow openings. So depending on the level, you might need to use like a needle nose pliers to hold on to the test strip to dip it. Just don't drop it in there. Put that off to the side. And we'll get out a test strip. Okay. Make sure you put the cap back on right away. These are sealed and moisture sensitive, so we want to keep that cap on. So how this works is there's 3 scales right here. This one is for blue coolants, this one's for red coolants, and this one is for others. And this section right here is for the coolant freeze point. The coolant freeze point is this pad at the very tip nearest the end here. Notice how this is a long portion and there's not a test pad here. This is your handle. And then the pH, okay, is going to be the pad nearest the handle. So when I go to dip it, I need to dip it all the way in. There are instructions on the bottle about dipping it and the amount of time needed. So we want to make sure that we review that before we try to use it, because you have to dip it in there for 2 seconds, then shake briskly, and then we need to take our reading within a certain amount of time. Okay, so let's go ahead and see if we can dip this all the way in. 2 seconds. Shake. And then we have a green coolant, and so we're going to try to compare the color best we can. 100% freeze protection. So that would be good. And then if we check our pH, see, that's right around in between there-ish. So that would be, come on, maybe an 8, 8.5. Okay, and then we record our results on our lab sheet. Please do try to keep the label clean. Try not to get coolant on it or mark up the label with dirty fingerprints so that it's easy to read and see the colors. And then make sure those coolant test strips get put into the garbage. But that's how we're going to use the test strips. And then we need to make sure we put the cap back on. So we got to line it up once, twice. Okay. Moving on to other fluids underneath the hood here. Brake fluid, once again, I can take my light, shine it through the container, which you guys can't really see anything that way. If we take a look, I can shine my light, and then if I give it just a bit of a wiggle, you can kind of see the color difference there. There's light on top, and then it turns dark brown. That spot right where it transitions is my fluid level. Similarly, with the power steering, give it a bit of a shake, You can see the fluid level, and you can see our min and max lines there, and you can see that at this time we are below the min. Similarly with the washer fluid, if I shine my light down, you can see the blue at the top of the jug there. Oftentimes I can give that a bit of a shake. Might be hard to see at this particular angle. Get our air filter back out. Checking my filter condition. I can either hold it up to the light in the shop, or if I have a light, I can hold my light behind it. And what I'm looking for is to see the degree of light that comes through the filter. In this case, not a whole lot, and that's a pretty strong light. Make sure that this gets put back. Oops, seal came loose here. We gotta make sure that gets fixed before we put it back together. All right, moving on to the battery testing. So we've got the vehicle battery right here. Move the clipboard out of the way. We're going to use a battery tester to just give it a quick test to determine its state. In our shop here, we're going to be using the Accuracy Plus. It's got a red and black clamp, red for positive, black for negative. Anytime we make connections to the battery, it's generally good practice to go ahead and do positive first when you're making a connection, negative last, and then it's the opposite when you take it apart. So how this particular tester works is we've got different tests. We don't want to do a system test. We want to do a quick test. So we're going to press the down arrow twice, and then we're going to press go. It's going to ask us to wiggle the clamps to make sure we got a good connection. So just give them a little bit of wiggle. Make sure they got a good connection and we have a reading that's maintained. And then we press go. And then it's going to give us our results. Our OCV, or open circuit voltage, is 12.98 volts. CCA, cold cranking amps, in this case it's 496. If we arrow down, we can see our cranking amps is 620. And our amp hour is 62. And then it starts over. So when we break our connections from the battery, we'll do negative first, then positive. And once we get that filled out there, it's time to flip it over and do the back side. On top of the sheet in the back, you're asked to sketch out the cylinder numbering and arrangement, spark plug wiring and firing order. Since we're going to be doing a digital version of this, I'm going to change this to leave instructions to use Shopkey to find the cylinder arrangement and firing order, and you're going to paste a screenshot that you found the firing order in Shopkey Pro into your digital lab sheet. And I will insert a clip here on how to do that.
Alright, as promised, how to use Shopkey to locate the firing order and cylinder arrangement and numbering of your engine for your lab. So as you can see, I've got the digital version of the lab sheet up on half of my screen, just like you might. And then I've opened another tab and I've gone to shopkeypro.com. Keep in mind that this only works when you're connected to the school's Wi-Fi. So you go to here, you just simply click login and you wait. Once you're here, we need to enter in the vehicle information. And if we remember the VIN, it was 1.7, but you can see we have several options. It was the ES1. This is something we haven't covered a whole lot yet, so if you need help, this is where you can come to me with your Chromebook in the lab, and I'll help you walk through it. And we click use this vehicle. So at this point, we've got our four common things. We got commonly replaced components, common DTCs, common symptoms, and common lookups. Sometimes it's a good idea to check the common lookups, as fire and order might be one of them. If not, no big deal. Up in my OneSearch Plus search box, I'm going to just type in firing order, and you might see it pop up here with autocomplete. And I'm going to click on fire and order underneath search results and specifications. Here's my fire and order here. Okay, so I can take a screenshot of just the fire and order, or I can exit out of this and I can go back to maybe diagrams, and now you can see here I have my fire and order, but I also have a diagram of the cylinder numbering. So here's the front of the engine where the belts would be for the pulleys, and then here's my cylinders 1, 2, 3, and 4 along with the fire and order. So at this point you would capture a screenshot on your Chromebook, which I forget what the keys are offhand, but I have a video in Power School that shows you how to do that. You'd want to drag a region across the fire and order and the diagram and grab just what you need so that you don't have too big of a screenshot to fit. For the video demonstration here, I'm on a Windows machine, so I'm going to use the snipping tool, and I'm going to grab some info here. I'm going to copy it to my clipboard. When I go to paste it into the lab sheet, I want to make sure that my cursor is blinking on the right side of my picture, and then I'm going to do Control V to paste, and you're going to see it's going to paste it in huge. So I'm going to click on it, and I'm going to go find a corner with the little angle arrows, and I'm going to shrink that down to something that's way more meaningful in size. Okay, maybe a little bit bigger than that. And it might bump some stuff down, and that's fine because it's a digital document, but if that bothers you, we can cut that out of there, and we can come down to the bottom, put your cursor down on the bottom, hit enter a few times to get to a new page, and you can put it on the third page, and then up here you can just type C below, and then make sure that we check that it came from Shopkey. So that's how we're going to do it in this new digital age. Any questions or need assistance in the process, by all means come find me in the lab.
After that, we're going to take a look at some hoses and then the belts. So let's talk about hoses and identify the upper and lower radiator hose as well as the heater hoses. Alright, so upper radiator hose is this guy right here. So if I move our fender cover, it's going to go from the engine and it's going to go over to the top of the radiator right by our radiator cap. So that makes this the upper radiator hose. And when we're looking at it, we want to check to see if it's saturated in oil, if it's swollen around the clamps. And then a quick test we can do is a fingernail test, where I take my fingernail and I just kind of give it a pinch. Nothing super hard, but I just want to give it a pinch and see if I can leave an impression of my fingernail in the rubber, in which case I can't. And it feels good and it feels firm when I try to squeeze it. So that hose appears to be in good shape yet. You can see that there's another large hose beneath this one, and this would be the lower radiator hose. We're going to do the same thing to it. Sometimes, however, when you go to give these a squeeze, you might find that it feels like there's a metal spring inside of there. In some vehicles, they do actually have a metal spring to keep this lower one from getting sucked flat from the suction of the water pump. This particular vehicle, both hoses are on the same side. Sometimes you'll have the upper hose on one side of the radiator and then the lower hose on the other. So you got to look for that. And then lastly, heater hoses. This engine bay is a little bit tight in the back here, so they might be a little bit difficult to see or point out on camera. But if you see that rusty hose clamp on the hose right at the tip of my flashlight going into the firewall, that is one of two heater hoses. The other heater hose is directly underneath it and proving to be difficult to get the light and camera at the same angle. By the way, while we're back here, here's another spot you can find the VIN number for your vehicle. So go ahead and cover that up so nothing falls into it. Move on to the next item of our lab sheet here, which is going to be belt type and condition. Okay, so in talking about belts, I have some sample belts here. And so if we take a look at these, we'll take just the V-belt for now. The V-belt is a V shape if we were to cut it apart and look at the cross section, but it's got two angled sides. You can see that the inside of the belt is skinnier than the outer or back side of the belt here with my thumb. What we're looking for is this edge right here, the side of the belt. That's the surface that we're looking at. We're looking to see if that's shiny and polished looking or if it's dull. So that's a V-belt. Next, we have a multi-rib belt. They're smaller belts, usually go around 2 or 3 pulleys at a time. And on the inside, if I flip them inside out here, we've got multiple ribs. And I've got a new one and a really worn out one here for comparison. So the new one is on the left, and the really worn out, cracked one is on the right. You can see that the rubber is cracked and is starting to come apart, and if we look through this belt enough, we'll probably find some sections where there's entire ribs that are missing. And so this is on the right what a worn out belt would look like, and on the left is what they look like when they're new. Some of the newer belts are made of a newer rubber, and they don't wear or dry out and crack like the older belts do. And so to check some of the newer belts, we actually need to use a belt gauge. And I'll insert a video clip of that here. Okay, so over at the corner of a workbench here, I've got our belts, and I've got a couple of belt wear gauges. I've got one from Gates and one from Naco. If you know which brand your belt is, that's obviously very helpful in making sure that you choose the right gauge, because they might be a little bit different from one brand to the next. I'm at the corner of the table because I want a flat surface to put the belt on when trying to do this. And how this works, I'll do the Gates one first, is on the bottom side of the Gates are a couple of little ridges. And what we do is we put those over the V-ribs in the belt on a flat surface, and then we check to see how much side-to-side rotation we can get from it. This being a brand new belt, the little bit that I'm getting is because I'm actually flexing the actual rubber of the belt, so you need kind of a gentle hand. But this one doesn't really move at all, and it doesn't really sit down very flat either. That's because these grooves are nice and small yet, and so this doesn't fit in very well. If we take a look at the Naco tool, it's a little bit different. It's got little peaks that go into the ribs of the belt, and then we would look to see how much side-to-side play we get. We could even shine a light behind and see if any light comes through. Additionally, this part right here fits into the rib, and then we feel to see if this part stands proud of the ribs. If we can feel it above the ribs, the belt's okay yet. If we can run our finger across the ribs of the belt and not feel this part, then the belt's too far worn and needs to be replaced. And then lastly, if I have 10 or more cracks per inch inside this window, it's time for a new belt. And so that's how we use those two gauges on a new belt. Let's take a look at them on a worn belt. Okay, so here's another belt. You can see the edges of the rib are kind of shiny. If I keep it flat, this does seem to rotate, but it does sit down and in a little bit further. Try the other one here. Let's see if we get this one. You can see that we've got a little bit of light shining through. Okay. And this part sits much further down into it. I can still feel it very slightly, but not nearly as pronounced as the new belt. I don't see any cracks in this one. But wait. There's more. This one, you can plainly see that there's far too many cracks in it. If we try the Gates gauge, it actually fits pretty good yet. Try the Daco one. Put the light behind it. Not a lot of light. The wear gauge sticks up quite a bit, but it's definitely not passing a crack test. Okay, so that's how we use the belt gauges on the belts. And our other type of belt are our serpentine belts, which are very long belts. Typically, you get one serpentine belt that goes around all of your accessory drives. Just like the multi-rib belt, whoops, we've got multiple ribs. Okay, and if we take a look, you can see the one on the right here, also a very worn belt with lots and lots and lots of cracks. But one of the things that we want to make sure that we look at on these belts is not just for the cracks, but we want to look at the side of the ribs here. And we're looking to see how shiny or polished the edge of these little ribs are. Because as the belt slips, these will get polished and hard and not grip the pulleys as well. So we want to look at that. The belts are right down here. Here's the power steering belt. And if we take a look, you can get a light down there. You can see it goes down to the main crank pulley there. And there is actually a second belt behind there that goes from the main crank pulley to the air conditioning. So this vehicle actually has two belts. And you can see they're kind of buried, so that air conditioning one might be better inspected from underneath the vehicle. We're going to do the best we can to inspect them from the top if we can, and if not, this is where getting some instructor assistance or approval to move on without is good. Up next would be spark plug wiring. Being that this vehicle is coil on plug, there are no spark plug wires to actually inspect. So we can either move on to the next item on the list, or if you're inclined to do so and we have the time, we could go ahead, pull this cover off, pull the nut, and unclip it and pull out the coil and take a look at the coil and the boot on the end of the coil in place of the spark plug wiring. Fuel injector wiring, well, we talked about the fuel injectors earlier, and these ones are pretty hard to see much of it, and the fuel injector wiring has been encased in a black loom, so it's a lot like this one right here. So it all looks pretty okay, but some vehicles, the wiring's a little bit more exposed. We want to make sure that it hasn't hardened, dried out, cracked, or maybe even been chewed. Alright, so the last few things we're going to try to locate underneath the hood is a PCV valve, otherwise known as a positive crankcase ventilation. If you remember that sticker before, the VECI sticker, it showed us a general location of the vacuum line and where that is. On this particular engine, it's a little bit difficult to see. It's down there on the side of the intake manifold, to the point where I can't really get a good angle to see it, even with a light. That hose in the background there, that would be the hose that goes down to it. Okay, but it's there. What I do have for you, however, is this here. This is an example of a GM PCV valve. And this one just pushes into a rubber grommet, and then the hose connects to the barb end here. And to check them, just give them a bit of a shake and see if we can hear them rattle typically. If there's no rattle, that usually means that they're gummed up and they need to be replaced. Moving along to other items to look for is we're going to try to identify and locate some evap emissions components underneath the hood. The first one on the list is the canister. I'll tell you right now that this vehicle, the canister is down by the fuel tank, which is the case for many vehicles these days. But they come in all shapes and sizes. Here's an example of what a Chrysler canister might look like. Okay, there's a valve on top, and then there'd be some hoses going to it, as well as an electrical connector or two. This one clipped onto the side of I think it was a 300M fuel tank. And some look different. Some are a little bit more round, some are a little bit bigger, some are a little bit smaller. Other items to look for would be a purge valve or the green test port cap. You may have seen this in earlier shots, but right here is that green test port cap. And then a little bit further over, underneath that wire connector there, is the purge valve on this particular engine. Like with other components, those will vary based on the engine and the manufacturer and when it was made. And lastly, we'll do some visual radiator check to determine if it's leaking, as well as what it's made out of. Brass and copper radiators, those pretty much have been around for a while. You will find that most of the radiators you see today are aluminum in plastic construction. And then the battery case. We'll take a look at the battery case here. We're looking to see if it's bulged. If it's wet looking, you'll notice that around here we can see that it's damp looking. Remember, don't actually touch that. Usually that would be battery acid that may have leaked out of these caps. And we'll take a look at the battery cable in the ends and the terminals of where they bolt onto the post, or maybe they're the side terminal where they screw into the side of the battery. We'll take a look at those, as well as check for the presence of a battery hold down. So this battery hold down's here. It's intact. It's keeping the battery down. But if we take a real close look at the terminal here, we can see that the copper wire, there's a little bit of it exposed and it's turning green. And we're getting some white and greenish crusties growing around the terminal here. This would be an example of a corroded and dirty ends that need cleaning. At this point, we're pretty much done with the lab. You can leave any notes about areas that might need work, or maybe you found some broken or missing parts. And then we'll have our final structure check and conversation, in which case there'll be time to clean up and turn in your lab. Hope that was helpful in giving you some information about how to do some of the checks and look at things for the lab. Any questions, come find me in the lab. And thanks for watching.